All right, welcome everybody. Today we're going to talk about Calc Lesson number 10. This is still section 2.2, but now we're going to specifically talk about finding slopes and equations of tangent lines. Now that you've learned all the rules and all the shortcuts in lesson 9, you should certainly be using them. So have your notes from lesson 9 or your formula sheet handy throughout this lesson. Let's go ahead and take a look here at example 1. Find the slope of f of x equals x to the fourth for each given value of x. From this point forward, when you see the word slope, slope of what? A tangent line. How do you find the slope of a tangent line? You need a derivative. So when you see slope, you need to think derivative. So the derivative of x to the fourth, hopefully you remember, is quite simple. Bring down the 4. Take the x to the 1 less power, which would simply be 4x to the third. If they're asking you to find the slope at x equals -1, that means you want to find the value of the derivative, f prime, at -1. So -1 cubed would be -1. -1 times 4 would give you a slope of -4. If you want to find the slope at 0, that means you want to find the value of the derivative at 0. 4 times 0 cubed would be 0. If you want to find the value of the slope at x equals 1, that means you're finding the value of the derivative at 1, which would be 4 times 1 cubed, which of course would just be 4. When they say find the slope at the point -216, they're not really trying to trick you, but what they are asking you to understand is that you only need the x value. That's all you need to find the value of the slope anywhere. So you're going to find the value of the derivative at -2. -2 cubed, that would be -8. -8 times 4 would give you a slope of -32. So if it seems easy, if it seems straightforward, it is. Again, when you see the word slope, slope of what? A tangent line, that means derivative. All you need to find the slope is the x value of the location, and you plug it into the derivative. That is actually quite different than the next problem, where they ask you to find the equation of the tangent line. When they ask you to find the whole equation of the tangent line, here they're looking for y equals mx plus b. In the previous example, if you had found me y equals mx plus b, it would be wrong because you found too much. And in this problem, if you only find me the slope, it would be wrong because you found too little. So important that you give me exactly what I asked for. So find the equation of the tangent line to x squared when x equals -2. So again, tangent line means derivative. So start by finding the derivative of x squared, which you bring down to 2, x to the 1 less power, which would simply be 2x. If you remember back to your Algebra 1 days, in order to find the equation of a line, all you need is a point and a slope. I like to call them the SOT for the slope of the tangent line, and the POT for the point of tangency. The slope of the tangent line always comes from the derivative, which in this case would be 2x. The point of tangency has to be on the original f, which in this case would be x squared. So again, you need a point, which I call the point of tangency, that comes from the original, and the slope of the tangent line, which comes from the derivative. And the magic value for each of these is -2. So if you're going to find the slope of the tangent line at -2, you're going to find the value of the derivative at -2, which would be 2 times -2, which would give you a slope of -4. Then to find the point of tangency, that means you have to actually find what is the point on x squared that this line goes through. So you have to find the value of just the f function at -2. So that would be -2 squared, which would be 4, which means the point of tangency is the point -2, 4. Once you have found both of those pieces of information, y equals mx plus b. So 4 equals -4 times -2 plus b. -4 times -2 is 8 plus b. That means that b equals -4. And for your final answer, y equals mx plus b. Sorry, there were an awful lot of 2s and 4s in this problem, but hopefully you can see where they come from. So again, not a difficult process, but the most common mistake that people make is they forget where does the slope come from and where does the point of tangency comes from. So that's why I like to refer to them as follows. Let's try another one like that. Find the equation of the tangent line to this function when x equals -1. So again, find the equation of the line. That's how we know that it's y equals mx plus b. We're going to go ahead and start. Tangent line means derivative. So -1/2 x to the 4th, bring down the 4 times -1/2. That would give you -2 to the 1 less power, x to the 3rd. Plus, bring down the 3 times 3 is 9, x squared, and then -2. Again, in order to find the equation of the tangent line, you are going to need the slope of the tangent line, and you are going to need the point of tangency. The slope of the tangent line always comes from the derivative, and the magic value here is -1. So for the slope of the tangent line, you're going to find the value of the derivative at -1. So if I look at the derivative at -1, that's going to be -2 times -1 cubed is -1, plus 9 times -1 squared is +1, minus 2. That's -2 plus 9 is -2 plus 9, or +2 plus 9 is 11, minus 2 is a slope of 9. The point of tangency means you're finding the value of the original function. Keep doing that. Not the f prime, sorry, just f of -1 in this case. So just the regular function. So that means you're plugging it here. So that would be -1/2. -1 to the 4th would just be 1. Plus 3, -1 cubed would be -1. And then -2 times -1, which of course be +2. So looks like -1/2 minus 3 plus 2. Looks like that is going to give me a y value of -3/2. So that means that my slope of the tangent line is 9, and my point of tangency is -1, -3/2. Again, find the slope from the derivative, find the point from the original. So y equals mx plus b. That's going to give you -3/2 equals 9 times -1 plus b. So -3/2, you're going to add 9, which means you're adding 18/2. So -3/2 plus 18/2 would be 15/2, which means your equation is y equals 9x plus 15/2. So the numbers don't always turn out perfectly, but easy enough to do as long as you remember where does the slope come from, the SOT, and where does the point come from, the POT. Finally, they might ask you for specific tangent lines, and that one in particular is the horizontal tangent line. So determine the points, if any, at which the graph of the function has a horizontal tangent line. Hopefully you remember a horizontal line looks like this and has a slope of 0. So determine the points at which the graph has a horizontal tangent line. That means you're going to find the derivative. Then you're going to set it equal to 0, and then you're going to solve if possible. That's what they're asking you to do when they say to find the points, if any, for which there is a horizontal tangent line. So we're going to start by taking the derivative, y prime. Bring down the 2 times 5 is x. Derivative of -20x is just -20, and the derivative of a constant is, of course, 0. That is the derivative. If they now want to find the specific slope of the tangent line that's horizontal, that means you're going to set it equal to 0 and see if there's a solution. If you add the 20 and divide by 10, I think you would agree that x equals 2. And because they're saying find the point at which the graph of the function, means you're now going to plug 2 into the original equation, and that'll tell you exactly where the horizontal tangent line occurs. So 5 times 2 squared is 4, minus 20 times 2 plus 12. That's going to give you 20 minus 40 is -20 plus 12 is -8, which means that at the point 2, -8, is where the horizontal tangent line occurs on this quadratic function. Because this is a quadratic, that would, of course, be the vertex or the minimum. Okay, one more. So y equals x cubed plus x, same thing. You're going to go ahead and take the derivative. Oh, you should be getting good at these. Should be getting faster and easier and, dare I say, fun. So 3x squared plus 1, you're going to go ahead and set that equal to 0. You're going to subtract the 1, you're going to divide by 3, and you're going to get negative 1/3 is equal to x squared. That should make you think for a second, because how do you get rid of a squared? You take a square root. How do you take the square root of a negative? Well, that's imaginary. So determine the points, if any. There are none. You could also say no solution. In this case, either of those would be fine. And again, the reason why is because you cannot take the square root of a negative. So pretty easy and straightforward, just a couple of problems here in number 10 to make sure. And again, just make sure you're answering exactly the question in front of you. Find the slope, find the equation, or if you're looking for horizontal tangent lines. So thanks very much, guys, and we will catch you next time.